Welcome to the AWS Greengrass session at today's IoT Web Day. We will talk about local connectivity and machine learning at the edge. My name is Metzner. I'm a Specialist Solutions Architect for IoT in EMEA. So let's think a little bit back, okay? So we were thinking, okay, if you could know the state of everything and you could reason on top of that data, what problems would you be able to solve? And we see today 6 business challenges in current IoT projects. Biggest challenge is how to get started, connecting large fleets of devices, ensuring the security of connected devices, connecting even more devices to the cloud, extending the IoT capabilities to the edge, and generating value from IoT data. Well, in this talk, we'll concentrate more on the edge side and on generating value out of the data. So out of those challenges, you see we have secure connectivity, messaging, we have gateway support, and support for endpoints. Additionally, handling large fleet of devices, security not only in the transit but also ongoing and auditable, and obviously with analytics and intelligence to generate value out of the data. So for the connectivity and the messaging itself, we have AWS IoT Core. Then in 2016, we created AWS Greengrass, which extends the capabilities of the cloud to the edge itself. Last year, we released Amazon FreeRTOS for constrained devices and IoT device management for handling large fleets, IoT Device Defender for auditing, and IoT Analytics for doing analytics and machine learning with IoT data itself. So you see the 6 business challenges are addressed actually with the services we have. In the end, the vision of IoT is way bigger than just an IoT platform, even bigger than a cloud platform itself. So from left to right, we briefly talked about the edge services from Amazon FreeRTOS and AWS Greengrass. Then we have the IoT services inside AWS, so IoT Core, IoT Device Management, IoT Device Defender, and IoT Analytics. But yeah, we have a cloud platform, which means you can use much more than just those services. You can use much more services like Amazon SageMaker or machine learning services or any other service which runs in the cloud, which could be your own service which you're running on the cloud, which could be a third-party service provided by your partner which is running there. So the IoT vision is way bigger than just an IoT platform or a cloud platform, and you need even more. You need actually partners that supply the hardware that integrate with the operating system like Amazon FreeRTOS. So you need to have edge hardware suppliers, you need to have gateway suppliers, you need to have connectivity partners as well, and obviously platform partners which build platforms on top of the services that we offer. And if you want to build something, often you need to have actually a consulting partner that is helping you to build the end-to-end solution. So the big vision looks way bigger than just a few services. And we have a solution for this big vision. So in this talk, we will talk only about a small portion here, but I think a quite important portion. So we'll talk about AWS Greengrass, which obviously also includes a little bit more also on the cloud side. So we'll also see a little bit more about AWS Lambda. But about that a little bit later. So AWS Greengrass. Biggest question is, where do you want to process the data? So you have the edge and you have the cloud. There are some constraints: the law of physics, law of economics, and law of land. Sometimes it's the connection from edge to cloud is very poor, and in this case it might make sense to actually do the processing on the edge and not in the cloud, because you're not able to reach the cloud in time. Or the law of economics, where you could actually transfer all the data to the cloud, but it doesn't make sense because it's so much data that the value itself for transferring the data is too high. Or the law of land. You're not allowed to transfer some parts of the data to the cloud. So to addressing this, we have AWS Greengrass, which provides you those options. And you can use that in a gateway, you can use that in moving vehicles, you can use that as an appliance or inside communication infrastructure. So the benefits is quickly response to local events, even if you're offline, even if you have poor connectivity, you can always respond. You have a simplified device programming model, because you're coding actually in the cloud and deploying and coding with the same programming models in the cloud, but deploy this then down to the device itself. And this can reduce the cost, because you're not needed to transfer all the data to the cloud. You can also just use some of the data just locally and do the computation locally. And it has AWS grade security, not only for the connectivity to the cloud, but also if you use it as a gateway. AWS Greengrass provides the same secure connectivity for your edge devices to the gateway itself, with managed certificates and so on and so forth. So in 2016, when we started Greengrass, we launched with local actions, with local triggers, so connectivity to the local broker, with data state sync, so the shadows can be synced to the cloud and back, and with security which we have in the cloud brought actually to the edge device. Today we have much more. As you can see, we have machine inference, so local machine learning inference, which we'll talk later a little bit more. You have local resource access, so you can directly from your Lambda functions call peripherals, access local file system, depending on how you configure this. We have protocol adapters. You will see this later on in the live demo. And we can update not only the Lambda function itself, but also the Greengrass software itself over the air. And direct integration with Amazon FreeRTOS. So FreeRTOS devices can directly connect to Greengrass and communicate with the Greengrass system. So coming to prediction on the edge. Most of the time you have two sides. So you have the data side itself, so the edge, where you have more or less infinite data. If you have a machine, then it can produce quite a lot of a big amount of data. If you think about the cloud has infinite compute resources. So building machine learning models, digging into all this data and creating models out of the training data is perfectly suited for the cloud. But running the model in the cloud with a lot of data, which is coming from the edge, well, sometimes you need to decide what to do when. And AWS Greengrass Inference solves that. So you're uploading the training data to the cloud, you're building your machine learning models with the services that run in the cloud, but then you create a model and deploy the model to the edge. And then you can just use the model and do local inference. So you can use prediction locally with a model that was trained in the cloud itself. So you see we have quite a big range of different services. Greengrass is used by a lot of different use cases. So we see in the demo an industrial gateway, but you see that it is used in automotive infrastructure and so on and so forth. So it can be quite flexible and used in different scenarios. And that's why we have a bunch of different customers using this already on their devices. So before we go forward to the demo and explain in detail how that works, just a heads up for Hannover Messe. We have our AWS Industrial Software Experience at Hannover Messe. So if you want to see especially AWS Greengrass live in action, so visit us at our booth in Hall 6, D46. So let's look at the demo that I've prepared. So we talked about connectivity, especially in industrial devices. You want to connect with some strange protocols or standardized protocols like OPC UA, and you want to run machine learning inference at the edge. And we'll look into this, how this can be done. So before we do that, later in this demo, you will see this demo setup. You see on the right hand side a Beckhoff C6015. It's a small industrial PC, and this one is running AWS Greengrass. It has connectivity to AWS, and it has connectivity to the local OT network. This is simulated by the gray Ethernet cable. So from the second Ethernet port of the C6015, we have direct connectivity to the left-hand device. It's a Beckhoff PLC with an OPC UA server on top of that. And we'll show you actually how to get a connectivity and how you can get the data from the OPC UA server to the cloud. First of all, if you log into your AWS account, you see the IoT services on the bottom right. So we talked on all of them already. So if you want to create AWS Greengrass deployment, we go to Greengrass, and there's a wizard actually to get started. So here's a Get Started guide, which is a wizard which will help you to get started. Just use the easy wizard creation because it will do a lot of things out of the box. IoT webinar. So let's create this group name. We have a core. The core is actually the device which hosts the AWS software itself. So this has its own certificate and authenticates to AWS IoT core, so to the cloud itself. And this is the name of the core device itself. And you will see what it will do. It will create a group which holds the configuration, which is way more than just the connectivity. We'll dig into this later on. It will register the device and will create some default policies and so on. So let's create this one. So now we have two things. So we have created the configuration itself. We have also created client certificate and a private key and a device-specific configuration. You can download this. And then you can download the Greengrass software itself. You need to decide for which architecture you need to download that, and just click here and download the software. And then you click Finish. So let's look what this Greengrass group looks like and what you can do with that. So you see here, and you will say later on switch to an already deployed Greengrass group. You see here the deployments, which is not yet deployed, so you don't see any deployments. So the Greengrass group holds obviously all the participants in the group. So if you have devices, so if the group acts as a gateway, you can add devices. The devices are managed from AWS IoT Core, so they need to register there. The certificates need to be registered there, but obviously the devices are communicating with AWS Greengrass locally. You have the core itself, where we run the AWS Greengrass software. Then we can deploy Lambda functions. This is here. We can add resources. So this could be machine learning resources. This could be access to peripherals, which we can assign to Lambda functions. And the communication inside the group. So for example, which device can forward the data directly to the cloud through AWS Greengrass, which part of the data is then, for example, forwarded locally to a Lambda function, and from a Lambda function then forwarded to the cloud. Something like that is defined in the subscriptions. And in the settings, you can define security settings. You can rotate the CA, so this certificate authority that is included in the AWS Greengrass, so a management interface for that, and the logging. So you see, you can also forward the logs to CloudWatch logs, so that you can analyze the logs in the cloud from the devices itself. So if we go to an already defined group, let's go to this group here. So this is a group that I've already created, and this group configuration is deployed on the gateway device that I've shown on the picture. So it's deployed on the back of our gateway itself, and this should connect to an OPC UA server to get data from an industrial device. So how do you do that? In our documentation, there's a sample Lambda function, and those Lambda functions can run not only like in the cloud by invocation, but they can run as a kind of process, which makes it easy to do things like custom protocols. And there's one Lambda function, I called it like this, and you see it's running infinite, and it has the ability to connect to the OPC UA server. How is this done? Lambda function itself is here. If I'm switching to the Lambda console, you can reach this by just clicking on the Lambda icon here and selecting the right Lambda function. If we look into the Lambda function, I've already prepared a Cloud9 workspace to dig a little bit deeper into this. If you follow our OPC UA adapter, you will create a Lambda function out of that, which includes a library to connect to OPC UA server. It includes a configuration and a subscriber module, which will then publish the data to either Greengrass or can be even forward the data somewhere. So what we need to do is actually we need to define the OPC UA server and the connectivity options. In this case, I'm just connecting without any certificate, but obviously you can add a certificate as well to secure the connection to the OPC UA server. So I need to know the address of the OPC UA server and obviously the node that I'm interested in, where I will get the data from. So already connected with an SSH tunnel to the gateway, and then use an OPC UA client to connect to the PLC itself. You see, this is a standard Backhoff PLC, and there's actually a demo running there, which is just exposing a sinus value, which will change over time through the OPC UA server, and we'll connect to the sinus value and get data once it's changing, and forward the data to the cloud. So this means we need to know the node ID itself, which you see here. So NS4 and as is main sinus. So you see here, this is the same node ID, and we need to know the connectivity. This is your localhost. This is just since I forwarded since I tunneled the connection to the gateway, since the PLC is not directly connected to my PC itself. The software, since the software is running on the Greengrass software, which is running on the gateway itself, it can directly connect to the PLC. So you can either define this URL like that, statically in the code, or you can define this as a property, and I'll show you this in a second where you configure this. So once you have created the Lambda function, you will need to publish a version. So you go here to publish new version. Let me just quickly change something so we can publish a new version. So we upload a new version, then we should be able to publish this. Publishing means we are fixing the version itself, since Greengrass will only deploy fixed versions. In this way, you cannot. It's just you cannot accidentally change your code and then have on different devices, for example, different Lambda functions. You have a fixed version, but still you have the ability to alias actually the version to just ensure if you update this, you can use the same alias and don't need to change anything in the Greengrass configuration itself. So we do, we haven't changed that much. Okay, we should really change something. Let's see. Yeah, obviously, we should also change to the latest version, and then we can publish a new version. Just leave it empty and it will create us a new version. You see version 4 is now the latest version, and in order to use the latest version, there's inside Greengrass, we can use an alias itself. I will come back to this in a second. The version itself looks like that. If you just add a Lambda function, you would be able to select the existing Lambda function. We have already done this here. And in order to do the OPC UA connectivity, we need to make this a long-running Lambda function, so this here. And we have used the alias local connect. And if we want to update this Lambda function, we just need to change the alias to the newest version. So we go to connect and change the version here to 4. We save it. And now the local connect alias has the latest version itself. So if we now do a deployment, the new Lambda function code will be downloaded to the Greengrass device. So you see a little bit more. So you see also that I can use environment variables, so OPC UA server, which you can use here in order to not hard code the IP address, for example, or other connectivity things. So you can change that up to your needs. So this is the code which will be running. It will connect to the OPC UA server and will get the data. And once it is changed, it will publish the data to an MQTT topic inside Greengrass. So then we need to do something with the data. So the data is arriving, and what you can do is you can say, hey, we want to use the data that the Lambda function is creating and forwarding this to the AWS cloud. Sorry. And we just take every data, or you can, for example, do OPC UA, something like that. And only this part of the data will be forwarded to the cloud. And for example, some other data is forwarded to another Lambda function in order to do pre-processing. So you see here, I've already created this. And this is it. So the only thing what we now need to do is we need to do a deployment. And then that's it. Not quite. You see here we have downloaded the configuration and the Greengrass software itself. If you follow the installation guide, you will see that Greengrass will install in /Greengrass. And the software itself looks like that. And you will actually extract the configuration inside this directory, which will include the certificates. And also the config itself. The config is a JSON file, which just includes the connectivity to AWS itself. And the Greengrass core will include the software and will hold the deployment, so the Lambda functions and all the rest that we configured in the group itself. So let's go to GGC and let's start Greengrass. So Greengrass is now started. And if we go to the test console inside AWS IoT, so I will show you quickly how to get there. So we go to AWS IoT Core, we'll go to test, and this means we can connect to AWS IoT Core and specify a topic and see what data is actually coming on top of this topic. And we now see that the gateway is receiving data from the PLC and it's forwarding the data to the cloud. So we can directly use the data in the cloud. You see it's changing a lot, obviously. But you can modify that. You can forward the data to a Lambda function, a second Lambda function, for example, that is running on Greengrass, that is pre-processing data and then just forwarding some parts of the data. For example, if something has changed to the cloud, up to you. So you see it's quite easy to connect an OPC UA device and forward the data to the cloud. If you now want to deploy a machine learning model, depends actually on the region where you're in. In Frankfurt, we don't have Amazon SageMaker. If you have Amazon SageMaker in the same region, you would be able to discover MXNet models that are created with Amazon SageMaker. But you can also use other machine learning models or even statistical models and deploy this down to Greengrass. For that, you would go here to resources, and let's quickly remove that. This is an old configuration. And you would be able to add a machine learning model from S3. So you'd be able to select a model itself from an S3 bucket and deploy this to down as a resource. And then the Lambda function can access the resource and deploy that. I will quickly show that in an already deployed device. So let's go here. This one has already resources that are deployed as a model. So this is a Valve model as a JSON file. We can go in there and you see you just need to zip the model itself. This is sitting on top of an S3 bucket, and you give a local path. And then the zip is downloaded to the Greengrass device, is extracted, and the Lambda function will be able to access the contents of the zip under /trained models, depending on what you define here. And then you can use affiliate the resource with Lambda function. You see here, this is a Greengrass basic analytics function, which will have, in this case, just read-only access to the trained model. You can also read-write that, depending on you, on your needs. And use the model, load the data, and you do the prediction inside the Lambda function itself. So this was the demo itself. Let's go back to slides. So just as a finish, we have seen actually how to get started with AWS Greengrass. We've seen how to connect to industrial devices with OPC UA. We've seen how to deploy machine learning models down to Greengrass. You will later on see how to create machine learning models with AWS IoT Analytics. So getting the data to AWS IoT Analytics, creating machine learning models with Amazon SageMaker, and here you have seen how to deploy that model down and do the prediction locally. And if you want to see that all in live, as I pointed out before, we are at Hannover Messe, so visit us there, and we have quite a nice demo. Till will talk a little bit more about later today on this one. And Now it's open for questions, so if you have any question, go ahead. Thanks.